All right, so to be able to make a kind of a control algorithm for our drone, we need a baseline, right? We cannot we don't have any notion, like let's say if we had a PID, we have no notion about like where the throttle will be, or or what is basically the model of the flying aircraft. So what we need to do is to basically first assemble our little prototype that we've seen in our video before, right? And so for that, I needed to put like the computer on the back of the aircraft. So yeah, I made this. So I made this little kind of I don't know, like a bathtub for the system with the computer and the sensor. And my goal is to put it on top of it. I don't know. We will put like some rough I don't know, fastening thing, probably some Gorilla Tape or something. And probably what I want to do is to put the battery at the bottom instead of the top. First, it will be like a little bit more stable, and that's okay, right? Like you've seen like probably a lot of like racers doing that, like putting that on at the bottom, so we can hack on our little computer like a little bit more freely. So I'll put the 3D print of this online, but you can see that, yeah, it took me a while to actually come up to the right solution. So a lot of prototypes. That's the top. My goal is to be able to actually put the little fan that you see there on top, maybe if it is overheating, because this thing is, especially if we use a lot of CPU, can actually accumulate a bunch of heat. So yeah, let's do that. Let's try to put that everything together, and we'll see you in the field, flying the aircraft and getting some data out of it. So here we have it, our little flying machine assembled and ready to fly. So let's see how it flies. While I'm there, I prepared the experimental setup, basically the target that we want to recognize, and some space around to be able to fly our drone. So back to base. It flew not bad, even with like those like I don't know, almost like 40 grams of like extra weight on its back. It was okay. Just it was a little bit windy, so it took a while for me to, you've seen that in the video, to stabilize a little bit the position of the aircraft, but we kind of made it, right? So so we'll start to analyze the logs. So how do we get the logs from Betaflight? It's pretty easy. You have the black box here. For me, to be able to only record what is useful, I bound a mode in there to be able to not only like erase the black box, because like it can get like full like very quickly. So I bound a button basically to be able to empty it, and one to start the recording or not, right? So that helps. And then in the black box tab, you have the mass storage mode, and that's the preferred mode to actually extract the data, right? So from there, you click on the activate mass storage device mode. It will show up as directly as a drive on your PC, and you just download the files, which are those .bbl files, and you go to blackbox.betaflight.com, and you'll be able to watch see those very low level data, right? That's always good for us, even if we use copper and so on the high end, right? It's always good to go back to basics, right? Like really like these low level information, to be able to see what actually happened on the aircraft, and pretty let's say where the propellers meet the air, basically level. So this is pretty easy. You can filter by type of things you want to see and so on. Yeah, I removed everything. What is interesting for us for this video is to get a baseline for the throttle, right? Because that's the first axis we want to manage. And but we need to know, right, like around what values the PID should be in between, right? And so that give us like a little bit of an idea of both the range and basically the hovering throttle. And so if you look at what happened here, look at those are my sticks, right? Like so you see that we had like a little bit of wind and probably like a lot of like gyro drift. It was probably not calibrated correctly, right? So I was like halfway almost on the right hand stick. So that's the basically if you look at the quad, that is the 2D position. Like basically, if you go to the left, the aircraft will go to the left, to the right. Down from there, it's going to be backward, and front is going to be front. And on the left-hand side, you will have the throttle that from 0 to from 1,000 to 2,000, right? There, that is yaw, basically, if you want to basically rotate your aircraft left and right. So what is interesting for us right now is the throttle, right? Basically from 0 to 1,000 to 2,000, right? And especially the hovering point. And when you look at the beginning, we can play that in real time. You see that once I take off, right, it's really not stable, right? You see that I'm throttling up and down. There is a lot of like lateral movement to be able to stabilize the aircraft. I succeeded here to stabilize it a little bit, but here again, like you are, whoa, it's going like all over the place. So this factor, we need to find an area where the flight is more or less stable. And also there is another factor is that your battery needs to be like kind of in the middle. At the beginning you have like way more battery than at the end, and that does influence the amount of throttle you will get. And what we want is kind of like a median situation, right? Really like the average that you would need to put to throttle, not like really close to the ground, but like something like 1 meter or so above, because like close to the ground you have a ground effect that also affects a lot the stability and the throttle there, right? So if you want to have like some clean air, you need to be able to hover a little bit higher, and that's what you see here. I think that's our spot. Like between those ones and these ones, right? Here you have like kind of a stable situation. You look at that. I'm almost not touching anymore. I'm like micromanaging the aircraft at that point, right? And that value is going to be the one that is really interesting to us. What we can do is to extract here, like in CSV, the data, and kind of get like a very like a data-driven approach. Basically, trying to see roughly where it is there. So it's like let's say 90 seconds in, between 90 seconds in and let's say there. So it's easy, 90 and 120. Okay. So I exported that there for you. So those are kind of like arbitrary values. So I just put that and offset them, right? Those are the timestamps. I removed everything else. There are like a bunch of columns for everything the thing is recording. We are only interested in RC command 3, which is the throttle, right? That's the first axis we will try to control with the computer. And we say between 90 and 120, right? And so let's go 190, okay, 91, 90. So already like a minute and a half within the flight, that's the middle of the battery, right? Exactly what we want. And okay, let's grab that. Wait. How can we do this? okay, let's write down what it is going to be, maybe easier. So between 45,000 and 45,000 and 120 we said, right? So it's going to be somewhere there, right? 65, 46. Damn it. Hope there is a mean value, something like average maybe. Average, okay, between, we said, this guy and 68, 540. Here we go. So we have our rough number. Yeah, we will use that as our kind of our zero value, and yeah, that's going to be our basically our floating value that we will get before we get the CV kicking in and get the tag and so on, right? And also what we can look at is maybe also the min and max. Yeah, that's very close, right? And max up. So that gives us an idea. Basically, that is going down, that is going up, right? And at the beginning, might be the range we, in terms of throttle, we will aim at. So we can clamp it a little bit, right? We don't want this thing to go like crazy when it overflows and go like to the moon and so on. So those are probably safe values where, yeah, we can crash without really damaging anything. All right. Thank you so much. That's going to be it for this video. It's a very short one. The next one is going to be about, adding all those components to copper and try to have like some pose with like what we tried, right? Like, but in a copper component, and then adding a PID that is actually already in copper itself. We already have a PID component, so we'll reuse that. And let's try it, right? That we are almost there, and we'll need to guess also the kind of like heights in terms of like what is the range of view of the camera. So we if we exceed that, like we just give up. And yeah, that's going to be cool for our first like in the loop flying. That yeah, can't wait to try. Thank you so much.